billion years ago. So now we have a rough idea how our Earth, everything that you see, came to be. So if you guys want to have a look at it later, send me your emails. I can send you the slides so you can go back and see. If you guys know this is an extra, formation of Earth Moon system, we have a theory, it's a pretty good theory, which says that it's actually a planet called TAC, which collided with the Earth, creating the remnants, and that remnants started to form a ring around the Earth, and then the ring collided with each other, and then it will create like the moon that we see today. Alright. Okay, now we'll see a video. Now we have covered the beginning of videos, right? Now what about the future videos? So now let's see. So some of you might have seen the video.
One day the universe will know why and how.
It's fine. I think it's loud enough. Yes, I'll do it.
The universe will die, but why and how? And will the universe be dead forever? And how do you know that? First of all, the universe is expanding, and not only that, the rate of its expansion is accelerating. The reason? Dark energy. Dark energy is a strange phenomenon that scientists believe permeates the universe. Until 1998, we thought the universe must work a bit like a ball that you throw into the sky. The ball moves up, but at some point it has to come down again. But the expansion of the universe is actually speeding up. That's like throwing a ball up and watching it fly away faster and faster and faster. Where is this acceleration coming from? Well, we don't know, but we call it dark energy. Einstein thought of it first, and then decided it was stupid. Now, astrophysicists have decided it is plausible. Trouble is, this is all very theoretical, and we don't actually know what the properties of dark energy are. But there are various theories, and they lead us to 3 scenarios for the end of the universe. Since its birth, the universe has been expanding. For unknown reasons, new space is created everywhere equally. The space between galaxies expands, so they move apart. The space inside galaxies also expands, but here gravity is strong enough to keep them together. In the Big Rip scenario, the expansion accelerates up to a point where space expands so fast that gravity can't compensate for this effect anymore. The result is a Big Rip. At first, only large structures like galaxies are torn apart, since space between the single objects expands very fast. Next, big bodies like black holes, stars, and planets die. Their gravity isn't strong enough to keep them together, so they dissolve into their components. In the end, space will expand faster than the speed of light. Atoms will now be affected, and they will just disband. Once space is expanding faster than light, no particle in the universe can interact with any other particle anymore. The universe will dissolve into countless early particles that won't be able to touch anything else in a strange, timeless universe. And you thought you felt lonely. 2. Heat death, or a big freeze. In a nutshell, the difference between a Big Rip and heat death is that in a heat death scenario, matter stays intact and is converted over an incredibly long but finite period of time into radiation, while the universe expands forever. But how does this work? Let's talk about entropy. Every system tends towards the state of highest entropy, like what we have in a batting backyard. Initially, it has different regions, but over time they will cool down and disintegrate until it's uniform. And this also applies to the universe. So while the universe gets bigger and bigger, matter slowly decays and spreads out. And at some point, after lots of generations of stars, all the gas clouds necessary to form stars will be exhausted, so the will die. Black holes will slowly degenerate and evaporate over trillions of years due to what's known as Hawking radiation. When this process is complete, only a diluted gas of photons and light particles remains until even this decays. All activity in the universe ceases at this point. Entropy is at its maximum, and the universe is dead forever. Unless, theoretically, it might be possible that after an incredibly low amount of time, there might be a spontaneous entropy decrease as a result of something called quantum tunneling, leading to a new Big Bang. 3. Big Crunch and Big Bang scenario. This is the most uplifting scenario. If there is less dark energy than we think, or it decreases over time, gravity will be the dominating force in the universe one day. In a few trillion years, the rate of expansion of the universe will slow down and stop. After that, it reverses. Galaxies will race each other, merging as the universe becomes smaller and smaller. Since a smaller universe also means a hotter universe, temperatures rise everywhere all at once. 100,000 years before the Big Crunch, background radiation will be hotter than the surfaces of most stars, which means that they will be cooked from the outside. Minutes before the Big Crunch happens, atom cores are ripped apart before supermassive black holes devour everything. Finally, all black holes will merge into a supermassive mega black hole that contains the entire mass of the universe, and in the last moment before the Big Crunch, it will devour the universe, including itself. The Big Bang's theory states that this has happened a lot of times, and the universe goes through an infinite cycle of expansion and contraction. Well, wouldn't that be nice? So what will actually happen to the universe in the end? At the moment, heat death seems the most likely, but we at Kronskazart hope that this dead forever stuff is wrong, and the universe will start over and over again. We don't know for sure either way, so let's just assume the most uplifting theory is true.
Just now they were talking about dark energy, right? Actually, even now we don't know what dark energy is. So we don't really know what's its role during the early phases of the universe. That's why I didn't really mention that. So but now we are seeing that it's accelerating. It's going even faster and faster. So that might affect our future of the universe. So now just summarize. So now we know what we have a rough idea what our early universe is made of, how it all came to be. But still, we are not certain about the first 1 Planck time. That seems really small time, right? But that is where our understanding of the universe breaks down, which means it's a big problem. It's the point where we actually don't know what we are actually studying. So that's actually very important. So this is why I'm giving a talk now, because some of you guys might be interested in physics, might be interested in cosmology. So now you guys, hopefully you guys have the future now to really go into these fields and find out quantum theory of gravity or any other theories that might explain the birth of the universe. Now after this, we'll have a Q&A session. So do you guys have any questions? No questions? It's okay. Yes.
If the universe is expanding, what are we expanding into?
What are we expanding into? I forgot to answer that. Actually, we are expanding, but we're expanding into nothing. Actually, this is everything. It's just getting bigger. It's getting further and further away. So when I say Big Bang is actually the birth of space and time, space itself. So beyond that, it's nothing. Yeah, it's actually nothing. It's everything that is.
So is Big Bang is Big Bang a black hole actually?
Big Bang black hole.
Is Big Bang a black hole? Is that
No. Black hole is where the conditions are actually similar, because both Big Bang, the first Planck time of the Big Bang, and the black hole, inside the event horizon of black hole, is about the same condition because our physics breaks down. So it's not the same thing. But if when you're talking about singularity, yes, that's where no other forces, everything just crushes into a singularity, infinitesimally small point. If you're talking about black holes and Big Bang. But it's not the same thing. Quiz. So is that it? Any other questions? Thought you had some questions.
What was the cause of the singularity in the starting of the universe? Why was it there?
As I told you before during the first Planck time, we don't know right what happened. So before that, but as Stephen Hawking once said, there was no before. Since it's the Big Bang, it's the birth of the space and time itself. The time itself started. You cannot really say before that like negative time. So far we don't know anything about negative time, like in terms of Big Bang. So yeah.
Suhasan, but first one is time.
What is time? No.
What is time?
Time is where things happen. For example, the law of entropy. The law of entropy states that over time there will be change. There will be increase in entropy, which means without time there wouldn't be any change in entropy, and there wouldn't be anything at all. Like let's say you're growing up. If let's say time freezes and nothing happens, will you grow up? Just freeze that. So time and space is where events happen. Mr. Batman, Jeff, do you want to explain about time? What do you think time is?
Well, there's an interesting question. We measure time according to our perspective. So probably the concept of time exists, but we have given definitions like we have quantified time. So without the quantity of time, there will still be time.
Yes, exactly.
Is it possible that the time that we're experiencing is just that's another for him. It's like we are experiencing time because we think that we're experiencing time yeah, because like exploring everything from our perspective. Time might not be existing, we might be even living in a simulation.
Even if you're dead.
Yeah, that's like the theory of it's like time is just something relative, but we don't really know if time really exists.
Everything in the universe is something we gave birth to in a sense. Sorry? Everything in the universe is something we gave birth to in a sense. Because everything you look around, you don't know what gravity is. You call it gravity because that's what you're experiencing.
Yes.
Right?
Yes.
Right. So you call it time because that's what you're experiencing.
Okay.
But for science, most importantly, when you're saying something, let's say a theory or something, we make sure that it happens even during our absence. Okay? So you say that
It must be true.
it must be true even without our
Yeah.
absence. Any questions?
Do you think time will go on infinitely?
Time will go on infinitely. That's why this future of universe, let's say the big rip or heat death, time probably will go on infinitely, but for the big bounce, let's say everything goes back, probably time goes back, or time will crash to zero and then time starts again. For them, we will still not sure. But it's entirely possible.
What is space?
Same expression as time because they are the same thing.
Explain about God particles. Explain about the God particles. Do you believe in the God particles?
It's Higgs boson. Sorry, we just call it God particle because it gives mass.
It really has nothing to do with God.
Yeah, nothing
I
to do
know,
with God.
but explain more about the God particle.
Oh, you mean the Higgs boson? They just recently discovered. It was first proposed by someone Higgs.
Suhasan. Have you ever wondered, right? We kind of have definitions for all the physics concepts in our knowledge, but we never have any proper definitions for space and time.
I got confused.
We never
Which is the
have
basis of every physics concept.
I think Einstein is a good definition for that.
What is it?
Just where things happen, which I think it is heavenly research from them. But I think it's where things happen, space and time. Events happen. Like it's a coordinate system in our universe. When something's happening, we need to say where it's happening and when it's happening, right? Without each other, without either of them, it's like something's wrong, right? So I think that's what space-time is. So it's a space-time where you need those units to state where a specific event happened. Got particular. No, I prefer his photo. Yes.
Okay, we said that in the previous video, we said that we first start from a point, right? We are all concentrated on a point. So if the universe is infinite, how can we start from a point?
It's a good question. I wonder that also. Because they say, now they're actually not sure whether the universe is infinite or not. But everything else started from one point. But what I think later, you are in the Astronomy Talk group, right? No. Can't remember. You want to okay. Because later we'll take down the questions, we will answer you. I'm not sure, but now what I think it is actually, since at the point, but anything must be conserved. That one thing. Any other people, any other idea to a question? Let's discuss. Anything should be conserved.
I think we use the term singularity, that means infinitely small volume, but that doesn't mean a point. It still has the 3 dimension, but it's still a 3D volume, a 3D space, but infinitely small. So of course, through inflation, it can enlarge and become an infinity, or we're not sure about that, or just like a very large volume as we know it today.
So the universe is not infinite.
We do.
Don't know about that, but I think it is. But Big Bang, from the theory of service, we know that it's the birth of the space and time, right? So when you're saying space, when volume is not zero, and time equals zero, volume must be zero, right? But we don't know. Our current physics breaks down, so we don't know what happened.
So answer, if Big Bang and black holes are both caused by a singularity, right? Why does, they are originated with a singularity, right? Why does one, like D1 was everything, one expands? What do you, what's the main, what makes it so different and such that one creates space, one D1 space, but by right, both caused by a singularity?
When I say it's a singularity, which means, and then before that it was a singularity, or before that, or when it was there, it all started from singularity. But now it's a bit different from black hole. Black holes, you guys know, it's just matter just being compressed to a very small point. It's like I could say it's a opposite of Big Bang. But we actually, for the inflation, I've already started to expand, especially to.
And actually, the black holes don't really take in space, they take in massive.
Yeah.
Different stuff.
Different stuff, but what we say is infinite density when it comes to density. That's any questions?
What is outside the universe?
But we don't know that. String theory suggests that a lot of crazy things. One of these multiverse. I don't know a lot of things, but we don't know. We don't have any proofs. But many scientists think that we won't be able to prove, even if there's another universe. There are a lot of different types of parallel universes. One of them, intersection. I can only think.
Are there alien sources?
Why are we diving? I don't know. Aliens. Another day. Next one. Going product video. No, we will finish the first slide, then we have time. Okay, you guys want to play the quiz? Yes.
Play.
Alright. You guys, if you go to the website here,